So this video is going to help you figure out how to find area problems when you know you have a parallelogram or a rhombus. And so you're either going to use equations to find the opposite sides, or you're going to just find the area by the base times height. So what do we know? Well, parallelogram is basically just a rectangle that's kind of sideways, and so the area formula, you need to know the base, so one of the sides, and the height. And so if it's over an angle like this, you're going to find the height out to the outside. So the height is always at a right angle. So for instance, in this one, if this is 10 and this is 7, the area would be 7 times 10, which is 70. Don't fight the temptation to just take two numbers and multiply them together, because there might be an extra number there, like a 20. But we don't measure height at an angle. What you can use when you know another measurement with the sides is that you might have a rectangle that you're trying to find a missing piece of information. Like if you know one side is 10, one side is 20, and you know that the opposite side is x plus 2 and the other side is 2y, you know that x plus 2 equals 20. And you know that 2y equals 10. You could find the missing variable. So we know opposite sides congruent. And in geometry, our formula is usually we set stuff equal to each other, or we add stuff up to equal 180, or we add stuff up to equal 360. So for this case, we know opposite sides congruent. If you're finding the area equals base times height at a right. You got to look for a right angle. And the other thing that you may get with an equation with a parallelogram is relations to the angles. And any two angles in a row, because we have a parallelogram, any two angles in a row are supplementary. So if I have this angle and this angle, and one of them is x plus 2 and one of them is 2x, I could do an equation, 2x plus x plus 2 equals 180. So any two consecutive angles add up to 180 together. So those two, you could go, these two add up to 180. These two add up to 180. These two add up to 180. So the things you keep in mind when you're doing parallelogram problems is that consecutive, sometimes we say adjacent, angles are supplementary. So they add up to 180. And those are the main types of problems you're going to see with the parallelogram. With the rhombus, we have some special things. We have all the stuff with the parallelogram, so consecutive angles add up to 180. But we also know a few other things. And I didn't mention in the last part that the opposite angles are also congruent. But in a rhombus, we have sides equal. So if somebody gives you one side as 2x plus 2 and the other side is 10, you could find x by setting 2x plus 2 equal to 10. So rhombus, we have all four sides congruent. So that's an equal. We still have consecutive angles supplementary. And then special to a rhombus, the diagonals are perpendicular. And the diagonals bisect each other in a parallelogram. So if you know one side is 4, the other side is 4. If you know one side is 3, the other side is 3. And that will help us also to find the area. If you know the base and the height, you can find the area. But usually the way you find an area in a rhombus is if you know the length of the diagonals. And there's a formula for area. You need to write this down. Area is 1/2 diagonal 1 times diagonal 2. And so if you know the diagonals, you can just plug them in. Oftentimes, though, we have information that we use ourselves here. So in this case, the diagonal this way is 8, and the diagonal the other way is 6. So 1/2 8 times 6 is 1/2 of 48, which is 24. So the things to be careful of, if they only give you those two sides, you need to make sure you write in the other two sides so that you can get the full diagonal. Don't just take what's on the picture, but 1/2 of the diagonals. The other thing to note is because this is a right triangle here, you can do Pythagorean theorem. So if I want to find side AB, I can just use Pythagorean theorem and to find it. So side AB would be the hypotenuse. So the sides of the rhombus are the hypotenuse. So 3 squared plus 4 squared equals AB squared. 9 plus 16. And you're using Pythagorean theorem just like you would on anything else. Take the square root to solve. So we have perpendicular diagonals, and we have the area equals 1/2 diagonal 1 times diagonal 2. So here's another sample problem. If we wanted to find the area, then we would need to write in the rest of this diagonal. So the area would be 1/2 the first diagonal, which is 12, times the second diagonal, which is 6. So the area is 36. If we needed to find the length of a side squared equals 3 squared plus 6 squared. And so our side would be the square root of 45. And you could find a decimal value if you wanted to, but you can just leave it as square root of 45 or simplify it into square root of 9 times square root of 5, which is 3 radical 5. And so we get all the information we need off of there. If this would have been a parallelogram and not a rhombus, we would have had looked for a height somewhere that was given, not necessarily just the length of the diagonals. So if they had told us this is a parallelogram, we'd need to know a right angle height that's perpendicular to a base, and it can be either direction. Usually it's up and down, but as long as you know something that's perpendicular to the base, if this is your base, then I need a height this way, whatever that distance is. And area is just like a rectangle, base times height.